Okay, I'm going to go over the sum and the difference of cubes, factoring them, and then you're going to set them equal to 0 and solve for them, just like we've done previously in the learning target. And then we're going to flip it over and we're going to do factor by grouping with 4 terms. So sum or difference of cubes. Your initial polynomial is always going to look like this. It's going to have some kind of term that has been cubed plus some term that has been cubed. So we'll see a couple different examples of this. Sometimes they're numbers, sometimes they're variables. But they always follow the same pattern when you factor them. And you can memorize this pattern, and I have a little way for you to do that right below here. So when we have a cubed plus b cubed, we can actually factor that into a plus b, and then it's going to get multiplied by a squared minus a times b plus b squared. And you might be saying, okay, that looks kind of just crazy. Well, yeah, a little bit, but it really is a way for you to just break down and factor the, that's the sum of cubes. Here's the difference of cubes, and it's going to be a minus b, and then a squared plus ab, or a times b, plus b squared. Okay, and there's a way to remember this, and the way to remember that is SOAP, S-O-A-P. So what does that stand for? Same sign. So if this is the sum of cubes, the first sign is the same sign. If this is the difference of cubes, the first sign is the same sign. Then opposite sign. So in the sum of cubes, we've got same sign, opposite sign. In the difference of cubes, we've got same sign, opposite sign. And then AP means always positive, and that's the last term, sign. And if you notice in both of them, they're always positive. So how do we actually use this? So what we're going to do is find A and B themselves first. So before you can do anything, you need to know what A is and you need to know what B is. So how can I do that? Well, B is obvious because the cube root of 1 is 1. But 64 might not be as obvious. So if you take your TI-30 calculator, to get a cubed root, there's not one button for that like there is for a square root. So we're going to enter the root, which is 3, second, and then this key right here that looks like X and then a radical sign. So your screen will look like this. So this is cubed root. And if I put 64 in here, I get 4. So the cube root of 64 is 4. So A is 4 and the cube root of x cubed is x. So my A is 4x and my B is 1. So when I sub this in here, I'm going to have 4x plus 1 times, now here's where it's a squared, so this is going to be 4x squared, which 4 squared is 16, so 16x squared, opposite sign, so a times b is 4x, and then b squared, which is just 1. So that's what you get when you factor that. So be careful, especially here where you're doing the a squared, that you're actually squaring that correctly. All right, so let's look at the next one. Again, let's name our a and our b. If you're unsure of the cube root of 27, I can put that back in here and I get 3. So my a is 3x. And the cube root of 8 is 2. So again, I'm going to sub that into the formula. I've got here, and this is the difference of cubes. So I'm going to do 3x minus 2 and then a squared, so that's 9x squared. Opposite sign, so it's a positive. And then a times b, which is 6x. And then b squared at the end, so plus 4. All right, so I've broken that apart. So now what you're going to do after you take the notes on the other side is you're going to practice this, and you're also going to use it to solve. So not just factor, but also solve. All right, so we're going to flip it over to the other side, and we're going to talk about factor by grouping with 4 terms. So we're going to take the notes over here. So when we do factor by grouping, it's exactly what it sounds like. We're going to group the terms together. So let's look at A. We've got 3x cubed plus y squared plus 9y plus 3. We're going to group these two together, and we're going to look at these two together. And we're going to pull out the greatest common factor. So in this case, my greatest common factor between these two terms is y squared. And then I can divide both of these by y squared to see what I have left. So that's going to give me 3y plus 1. And here I'm going to pull out my greatest common factor between 9y and 3, and that's going to be 3. So I'm going to divide both of these by 3, and I have 3y plus 1. So you know you did this correctly when these two match. You can't just write them and make them match. They actually have to match naturally and mathematically. All right, so from here, we can rewrite the repeated term, which is 3y plus 1. So really what I'm doing is pulling out this as a greatest common factor between these two things. And then my leftover, y squared and 3, I'm going to write right next to it. So I've just factored that polynomial. All right, let's look at another one. Sometimes the ones with different signs are a little bit more difficult, so just be careful. Again, I'm going to look at kind of these together and these together. My like term here, or I'm sorry, my greatest common factor here is x squared. So I'm going to divide both of those by x squared. I'm left with x plus 5. And here my common factor is negative 4. If you have a negative out front here, you definitely want to pull that out. Just be careful, because that's going to change the signs. This becomes positive x, and this becomes positive 5. Which makes sense, because I want these two things to match. And they do. So now I can pull out my repeated factor here, x plus 5. And then I'm also going to write the leftover, which is x squared minus 4. Now, x squared minus 4 is actually factorable, but for our purposes, because you're going to end up solving with it, I'm not going to make you factor that, because you naturally would just set that equal to 0 and solve for it anyway. So your job now is to do the practice problems and then have your teacher check them.